Hello and welcome to the Mathematics Learning Lecture Higher 4. Okay, so the first thing we need to do is to have a go at our key skills test. So this is the key skills test Higher Spring 2.1. It's on the front of your booklet. So pause now and have a little go at that. Pause now and have a little go at that. Give yourself 4 minutes to have a go at those questions. Off you go. Okay, so hopefully you've had a go at those. I'm going to have a go at some of these for you. So let's first of all have a go at this one here. Now I've put this one on here because people always struggle with the shapes when there's one inside the other one. But the way you need to do this, the two similar shapes are this inside shape here, the inside triangle, and then the larger triangle here, which is outside my shape. Okay, these are the two similar shapes. So I'm going to draw these, hopefully neater than I have just done. So there's my first one, and I've got my larger one, which is this one here. So on my smaller one here, inside here, we know that this length on the right is 4, so let's write that down. So the smaller one, the length on the right is 4, and the bottom length is 4. On this one here, on the blue one, the length of here is equal to 4 plus 4, which is 8. So if I want to find out my scale factor, first of all, my scale factor is equal to my larger similar side divided by my smaller similar side, which is 8 divided by 4. So 8 divided by 4, which is equal to 2 in this case. Now this one's quite easy, isn't it? Because we've got here the 4, which is the same. So it'd be 4 times by my scale factor, which is 2, which gives me my y value in this case, which is equal to 8. Perfect. So for this next one here, it's asking for the probability of picking blue and then blue, which is going to be these two branches here. So this first branch here and then this second branch here, like so. So the probability is going to be blue and then blue is going to be 1/5 times by 1/5, which is equal to 1 over 25. Okay, looking at this next one here, we've got to do a cumulative frequency graph. Now cumulative frequency means the running total. So we're doing the running total here. And to do the running total, we always look at the upper bound. Okay? So if I'm going to plot this one, they've already given you your cumulative frequency. So you don't need to do the adding up part. But we just need to plot them using the upper bound. So the first one is 20 and 4, which is here. The next one's 25 and 10, which is here. The next one's 30 here. And 49, so 30, 49, which is going to be all the way up here somewhere. The next one's going to be 35 and 58, so 35, 58, which is here. And the last one is 40, 60. And then we want a smooth curve coming through here, like so, like that. You can draw straight lines if you want, but smooth curve works as well. All right, for question 4. We've got a smaller number here. We've got 1, 2, 3 jumps to get it between to make it between 1 and 10. So that's going to be 5.22 times 10 to the power of, well, there's 3 jumps and I'm getting smaller, so it's going to be to the power of -3. With surds, I need to think about my square numbers, which is going to be root 4, root 9, root 25, root 36, I've missed 16, haven't I? Root 16. Okay, and I'm thinking about what square number goes into 8. Now here, I think it's quite straightforward, isn't it? You can see that it's 4. So it's root 4, root 2, and the square root of 4 is 2, so I write that as 2 root 2. For our upper and lower bounds here, it says that it's been rounded to 3 decimal places. That there is my accuracy, okay? So my accuracy here is 3 decimal places. So to find my upper and lower bound, it needs to be the number which I start with, plus or minus my accuracy divided by 2. Now, what I talk about accuracy is what it's rounded to. So it's rounded to 3 decimal places. So it would be 0.001 in there. It's always the unitary value of that divided by 2. So if I do that on my calculator, it's going to be 0.7975 and 0.7985, plus or minus that there. So let's check these answers and mark them in green. Zoom out a little bit here. So the first one here, 8 is right, brilliant. So that's 8 there. The next one here is 1 over 25, brilliant. Here from my upper bounds, brilliant. This one here, 5.22 times 10 to the minus 3, 2 root 2. And here you can see that it's plus 0.0005, which is 1 over 2. So you've got your lower bound and then you've got your upper bound there, like so. Brilliant. So we're going to have a look now at our examples. Okay, so today we're going to be looking at iteration. Now, I've put down the definitions here just because a lot of people think iteration is really hard, but it's actually not hard at all. Iteration is the act of repeating a process over and over again, often with the aim of approximating the desired result more closely. Now, you'll always be given that first term to sub back in. Usually this is called x1. Now, sometimes this is called x2. So it's worth just making, sorry, not x2. Sometimes it's called x0, but it's worth making a note. This is your first, here, this is your first term, okay? This one here is your first term, okay? And then this is the trick. You keep substituting in your previous answer until your answer is at the same certain degree of accuracy. So you're subbing in your previous answer to get your next answer into one of your formulas, okay? So let's have a look at these two questions here. All right. So this first one, here, this is your formula. So it says f of n is equal to 5 times by f of n minus 1 minus 4. Now all this means is that your next term here, your next term is equal to 5 times by your previous term minus 4. It's telling you what the formula is. Now this part here was the x1 I was talking to you about. It gives you your first term. So the way that we do this is I'll write down my first term, which is equal to 3. And to work out f of 2, my next term, we need to use this formula here, okay? Which says 5 times by my previous term minus 4. So it's going to be 5 times by 3 minus 4. 5 times by 3 is equal to 15, minus 4 is equal to 11. Brilliant. So then I've got 3, 11. To work out f3, I've got to then sub in my previous term into that formula again. So my previous term this time is 11. So it's going to be 5 times by 11 minus 4. So 5 times by 11 is 55, minus 4 is equal to 51. Brilliant. So let's have a look at this next one then. So this one here says that my next term is equal to 7 times by my previous term minus 4. This is our formula. So it always gives you my first term. In this case, it's equal to e of 1 is equal to 6. So let's write that down first of all. My first term, e of 1, is equal to 6. My next term, e of 2, is equal to 7 times by my previous term minus 4. Okay? So 6 take away 4 is 2. Times by 7 is equal to 14. Brilliant. And then to work out E3, which is what it's asking for, it's equal to 7 times by my... Now, remember, all of this is coming from this formula here. Okay, 7 times by my previous term minus 4. So 7 times by 14 minus 4. So then I've got to do 14 minus 4, which is 10, times by 7 is equal to 70. So there's that one, and there's that one there. Okay, let's just check those answers. Brilliant. So, let's have a look at the next one now. So, example 2 says the table below shows the values of x and y for x is equal to x squared minus 8x minus 10. Between which consecutive integers is there a solution to the equation? Now, I'm just going to show you a little graph here because this here is a graph, okay? And if I've got this here, my graph is going to look like something like this. There's my graph. Now we know that a solution to this graph is always here, where it crosses. Okay? Where it crosses my x-axis. Okay? Now notice when it crosses, here's where it's crossing. Before it crosses, here, it's a negative value. And after it crosses, it's a positive value. Okay, that's what we know. Before it crosses, it's a negative value. After it crosses, it's a positive value. So here, what we're looking for is we're looking for a sign change, where it changes from negative to positive. So minus 10, minus 17, minus 18, minus 7, here is where that sign changes. Between minus 7 and 22, that's where the sign changes, which means that my solution must be between 3 and 4. So it must be between 3 and 4 because of the sign change. Brilliant. I've got one more example to have a little look at. Okay, this is an actual past paper question here. And this says, using the formula n of x of n plus 1 is equal to 8 minus 5 over x n squared, with x of 0 equal to 1, find x of 1, x of 2, x of 3, and x of 4. So with this one here, we're using our first value, which is x of 0 is equal to 1. Now to work out my next value, x of 1, we're using this formula here, which is 8 minus 5 over the previous term, remember, this here is my previous term, squared. So for this one here, it's 8 minus 5 all over 1 squared. Because my previous term is 1. So let's work out what that is on my calculator. 8 minus fraction 5 over 1 squared, which is equal to 3. Brilliant. So my next term, x2, is equal to 8 minus 5 over my previous term, which is now 3 squared. So let's work out what that is. So 8 minus 5 over 3 squared is equal to 67 over 9. 67 over 9. So we're getting a little bit trickier here now. So my next term, x of 3, is equal to 8 minus 5 over my previous term, which is 67 over 9, all squared. So this is now getting tricky to type in. So I can type it in if I wanted to. 8 minus 5 over 67, I need the fraction, so 67 over 9 all squared, like so. And that gives me this big long decimal, so 7.9097779. 7.9097779. Now the problem with this is you need to be really accurate, and subbing in all these values isn't being accurate enough really. There is another way to do this, okay, using our calculator. But you need to know to be able to do two things. So if we wanted to do this just on our calculator, first we need to be able to store our first value. So if I want to store the first value, you type the first value and then press equals. And this will store your first value. And it will store it in the answer button. So this will store it in the answer button. Now you'll see what I mean in a second. So if I type in my formula, which is going to be into my calculator, 8 minus 5 over my previous value, which is the answer, because I've stored it in there, all squared, I'll show you what I mean. So here's my calculator. So the first thing I need to do is to store my first value. Now I know my first value here is 1. Okay? So let's store that value in here. So this is going to be 1, press equals, and then it's stored. To find out my next value, I then do 8 minus the fraction button 5 over the previous value, which in this case is the answer button, squared. So, because I know that 1 is stored, it always puts in the previous answer. So if I press equals now, this should be equal to 3. And there it is. Now because 3 is now stored as the answer, if I press this again, it should give me my next value, which is 67 over 9. There it is. So it's basically putting the previous answer in for you. To find out my next one, I just press equals again. And there it is. So to find out my last one here, all I need to do here is press equals one more time. And it will give me it. There you go. 7.9 200 2008 2617 2617, and then you're really accurate. So there's our first 3 examples. So have a go at the practice questions yourself. So pause now and have a go at those practice questions. Pause now and have a go at those practice questions. So give yourself 5 minutes to have a go at those. Okay, so hopefully you've had a go at those and you've paused. Well done. So let's go through these questions then. So the first 2 answers here were U3 is equal to 82 and I3 is equal to 50. The next one here, I'll zoom in so you can see them. So remember, we're subbing in, we're starting with minus 3.5. It's probably worth using the answer button to this one. It's very similar to the one I've just done. And here's our 3 values here. So mark those in green for me. I'm not going to read them out because I'll probably make a mistake. So here's your next one. So it's looking for an estimate here. 3 times it says, so you've got to do it 3 times. So it's looking for x3, which in this case is 0.82965333595. The next one here is it says show that there's a value between this and this. Now if I sub those values in, you should get a sign change. That's the point. Sub 1.5 into here, sub 1.5 into here, and sub 2 into here, and you will get that sign change. And the sign change shows there's a solution in between it. And then if I want to use iteration 3 times, I'm subbing in 1.5 into this formula here. 3 times to get this. Brilliant. So thank you for watching this learning lecture, and have a lovely day everyone. Remember, the only way to learn maths is to do it.